All right, good morning. So, this is our first day. We'll discuss about our first lesson. It's about introduction about hydrology. Okay, and after which about water cycle, precipitation, and rainfall characteristic. Just a short background lang, no? So, because you just submitted your video presentation, so we will just have some collaboration with the presentation. Okay. So sa mga na-appeal ang ilang presentation sa uh, uh, video lessons na to, I'll give of course a plus points, no, because they've done a good job. Okay, so let's begin for a short introduction. So we'll call on group 1 of section C. Okay, let's.
Hi mga beshes! Hi mga earnships! What's up? Kumusta kayong lahat dyan? Shoutout ako sa lahat ng civil engineering students sa patuloy na lumalaban for their future. Espesyal ang araw na ito kasi we'll talk about hydrology. At mas pinespesyal dahil kasama natin ang Group 1 members na walang iba kundi sina Sarah, hello, Vincent, Aldrin.
Hi guys!
Ikaw na naman?
Di mo ba na-miss ang mukhang to?
At higit sa lahat, si Miss Ira J. Anyways, for today, together with our team, we'll discuss about hydrology kasi many asked, what is hydrology? What is its significance? What is its importance in our lives, especially in civil engineering field? So, let's start with our hydrology journey.
Good day everyone, I am Sarah Pa, and today I am going to report a sort of introduction in this course title, which is hydrology. What is hydrology? The field of hydrology is of fundamental importance to civil and environmental engineers, hydrogeologists, and other earth scientists because of the environmental significance of water supply, major floods and droughts and their management, drainage and urban stormwater issues, floodplain management, and water quality impacts. In recent years, hurricanes and storm surge have caused significant urban disasters, especially along coastal areas where urban development has expanded rapidly. This text was written to address the computational emphasis of modern hydrology at an undergraduate or graduate level and to provide a balanced approach to important applications in hydrologic engineering and science. Hydrology is a multidisciplinary subject that deals with the currents, circulation, storage, and distribution of surface and groundwater in the earth. The domain of hydrology includes the physical, chemical, and biological reaction of water in natural and man-made environments. Because of the complex nature of the hydrologic cycle and its relation to weather inputs and climatic patterns, soil types, topography, geomorphology, and other related factors, the boundary between hydrology and other earth sciences, like meteorology, geology, oceanography, and ecology, is not distinct. There are also some application of hydrology in civil engineering, because engineering hydrology enables us to find out the relationship between a catchment surface water and groundwater resources. Hydrological investigation helps us to know the required reservoir capacity to assure adequate water for irrigation or municipal water supply in drought conditions. Hydrology is an essential tool in planning and building hydraulic structures. Hydrology is used for city water supply design, which is based on catchment area, amount of rainfall, dry period, and storage capacity. Hydrology also is used to find out maximum probable flood and its proposed sites, say for example dams. The variation of water production from catchments can be calculated and described by hydrology. It is used in connection with design and operations of hydrologic structure, designing dams for water supply or hydroelectric power generation, designing bridges, designing sewers and urban drainage system, predicting geomorphologic chances such as erosion and sedimentation. And don't you know that dam construction, reservoir capacity, spillway capacity, sizes of water supply pipelines are all designed on basis of hydrological equations?
So this time, we're going to explore hydrological cycle. So first of all, introduce ourselves to this key geographical word, hydrological cycle. And if we have to break this word down into maybe three parts, consider what it means to you. So when I think the word hydro, I associate it with a word similar, such as hydrate. And then when we hydrate ourselves, we have to drink water. When you think of the word logical, I think about something important to a sequence or in order, and following a certain pattern. And then to me, when I think of cycle, I think it's something flowing, some type of movement from one thing to the next. And what we basically have here, the hydrological cycle, is a more advanced term for the water cycle. The hydrological cycle or the water cycle basically tells us the journey of water and water particles make, in terms of their journey through the Earth's surface to the atmosphere and back again to the Earth's surface. NASA actually describes the hydrological cycle as a gigantic system powered by energy from the sun. It is a continuous exchange of moisture between the oceans, the atmosphere, and the land. And if we were to think about the hydrological cycle and its flow of water within the cycle, we have stores of water and flows of water. The hydrological cycle transfers water particles in a solid, liquid, or gas from your stores of water to your flows of water. Now your stores of water of a particle may be a gas, a liquid, or solid stay in that state for a period of time. So that could be, for example, in the ocean, or the sea, or river. It stays as a liquid form for some period of time. That is the store of water. A flow of water is when it moves from one state to another, and it might change its state or stay the same state. So for example, when we heat water from the sea, it will evaporate and it will condense and form a cloud. Now, in order for the water to move wherever state it's in, solid, liquid, or gas, from your sea to your cloud, it means to go through the flows of evaporation and condensation. So let's take the time to go through the entire process of the hydrological cycle. Let's start off with a body of water. Now your body of water could be a sea, it could be an ocean, it could be a river, it could be a lake, it could be a puddle. It just means to be a store of water that is the same place and in the same state, in this case, a liquid for a period of time. Over time, as the system is driven by the energy from the sun was then send the solar radiation to the body of water and will start to heat it off. What we then have is the store of water starting to transfer into a flow of water to the process of evaporation. So in this particular example, the sea, this body of water is being heated up so much that the water particles that turning from a liquid into water vapor, which is known as a gas, through the process of evaporation. As this water vapor begins to rise into the atmosphere or the sky, it will cool and become to form condensation. These water droplets are beginning to cool down because they're leaving the Earth's surface where the solar radiation is the most concentrated of warm. That is why when you go on our place, for example, is always a little bit colder because you're high in the atmosphere. The process of condensation then starts to join its water particles together, which then eventually, when collecting enough, will form clouds. So clouds in this case is your next star in a hydrological cycle. When these clouds gets large enough and the water vapor becomes too much for the clouds to hold, the cloud will eventually give out precipitation. And what is precipitation, Sir Aldrin?
Precipitation is the final form of hydraulic cycle. Precipitation is the general term of all forms of moisture originating from the clouds and then it falls to the ground. It is that portion of hydraulic cycle in which atmospheric water vapor is condensed, forming water droplets sufficient large that gravity causes them to fall to the earth.
We have here a short video presentation about the different types of precipitation, or the common different types of precipitation. So let's watch this together and learn something together. So it was shown in the video presentation that different are the common types of precipitation, but those are just four, and those are the common types of precipitation. So we also have here the 9 different types of precipitation. So here's the list. We have here first the rain. The second one is the drizzle. The third one is the mist. Next is the sleet, freezing rain or glaze, the rain, the snow, the hail, and lastly, the graupel. So let's discuss these 9 types of precipitation one by one so that we may be able to identify each type. So we have here first, the first type is the rain. So there are different types of rain also. It's the light rain, the moderate rain, and the heavy rain. So it has an approximate size of, the water drop size has an approximate size of 0.5 or 6 mm. The light rain has an approximate size of 2.5 mm per hour. Then the moderate rain has an approximate size of 2.5 mm per hour to 7.5 mm per hour. And lastly, the heavy rain, it has an approximate size of 7.5 mm per hour. So the state of water is liquid. So let's read the description. It is generally produced by nimbus stratus or cumulonimbus clouds. When heavy, size can be highly variable from one place to another. So mo ni siya ang if ever wala pa ta kabalo sa rain. So mo ni siya ang images or examples sa or images of rain. Mo gid siya. So mo na siya. We have here the two photos. The next type is the drizzles. The drizzles has an approximate size of less than 0.5 mm. So the state of water is liquid. It is a small uniform drops that fall from stratus clouds, generally for several hours. So mo ni siya, we have here the photos. So mo ni siya ang photos sa drizzle. So in other term, mo na siya ang sa Bisaya pa mo na siya ang tarigsik. So the drizzle. The next type is mist. The mist has an approximate size of 0.005 to 0.05 mm. The state of water is liquid. So, droplets large enough to be felt on the face when air is moving 1 meter per second, associated with stratus clouds. So, muna siya. Muna siyang photo sa kaniyang mist. So, di ba dim siya na siya'y clouds. So, mist water drops are so tiny, they remain suspended in the atmosphere. So, basig, there are possibilities nga na misconception about sa fog ug sa mist. So, let's differentiate this one. So, the fog is a cloud that reaches ground level, even if that ground is a hill or mountain top. So, while mist forms wherever water droplets are suspended in the air by temperature inversion, volcanic activity, or changes in humidity. So therefore, fog is denser than mist and tends to last longer. So the next one is the sleet one. So it has an approximate size of 0.5 to 5 mm. So the state of water is solid. It is a small spherical to lumpy ice particles that form when raindrops freeze while falling through a layer of sub-freezing air. So while nagkatagak ang kaning kuan, raindrops nag-freeze na siya. So matagak siya sa kuan, sa ground or sa earth, kuan na siya, ice. Muna siya small spherical lumpy ice particles. So here's the photo. Muna siya ang example sa sleet. So, sleet are the ice particles of sleet are small. Any damage is generally minor. So, because gamay siya, gamay ra pud ang iyahang damage. But, sleet can travel hazardous. So, the next type is the freezing rain or glaze. The freezing rain or glaze, its layers has an approximate size of 1 mm to 2 mm thick. The state of water is liquid. It is produced when supercooled raindrops freeze on contact with solid objects. Glaze can form a thick coating of ice having sufficient weight to seriously damage trees and power lines. So, mo ni siya ang picture sa kaniyang glaze or freezing rain. So, as we can see, ang mga trees, cars, even mga benches, na puno siya og ice. Gikutan siya og ice. So, that's why ang freezing rain or glaze can damage trees, power lines, or even or different objects because of his heaviness. So, tungod sa ihang kabugaton, makahimo siya pag-damage sa usa ka object. So, the remaining types of precipitation are going to be discussed by my co-reporter.
Good afternoon, sir. So, I will be now discussing the remaining types of precipitation, which is the rime or rime ice. So, it has the approximate size variable accumulation, and its state of water is solid. Rime ice deposit usually consisting of ice feathers that points into the wind. So, this delicate frost-like accumulation form as super-coated cloud or fog droplets encountered objects and freeze on contact. So, rime usually dili lang siya sa snow mo-occur, but also when the weather or it has cold temperature, the fog droplets encountered objects and it will freeze on contact. So this will be now the result, as we can see here in the image. Now, the rime ice, it has the difference between the freezing rain, because as my co-reporter reported earlier, that the glaze, it has also the cold temperature, but ang kalayan nila is tubig yun nga ang mo contact na solid object, no? Sa earlier, the image seen, kadtong car, ang hinungdan na to tungod kay dool siya sa dagat, then the wave smashing to the seawall, then the water dito padulong sa kotse. So mga to ang resulta nga na froze ang car and the trees. Next one is snow. Now it has the approximate size of 1 mm to 2 cm and it is solid. The snow have the crystalline of nature. It allows to assume many shapes, including six-sided crystals, plates, and needles. So snow produced in super cold clouds, where water vapor is deposited as ice crystals that remains frozen during their descent. So later on, these types of precipitation nagdepende po din siya sa temperature. Later on, I will show you the the process of this precipitation. Now, next is the graupel. So it has the approximate size of 2 mm to 5 mm and it is solid. The graupel, sometimes called soft hail. Graupel forms as rime collects on snow crystal to produce irregular masses of soft ice. Now, these particles, because of these particles, are softer than hailstones. Now, as my co-reporter uh, shown the video clip a while ago, the hailstones are much larger. They normally flatten out upon impact. Now, the difference here, the graupel and slit. Now, the slit is a small ice particles that form from freezing of liquid water drops, while the graupel here are soft and small pellets form when super cold water droplets. When the ice rime fall to the ground, it forms as hail. Now, graupel forms as rime collects on snow crystal to produce irregular masses of soft ice. Now, the next is the hail. Now, the video presented a while ago from my co-reporter, the hail is much larger from the graupel and the slit. So it has the approximate size of 2.5 mm to 10 mm or larger, and it is solid. So when this continue hailstorm, it will be very dangerous to human being. It's very hazardous, no? As we can see the images here, it's very large, and kung maigo kita ani, I'm very sure na we bleed bukol jud. So now,
Hello everyone, it's me again, your hydrology today. So we'll talk about the rainfall characteristics.
Ang rain is a form of precipitation, and ang term na rainfall is used to describe precipitation in the form of water drops of sizes larger than 0.5 mm. So, ang rainfall is na characteristics. So, unsa ka importante ang pag-determine as a future engineer sa rainfall characteristics. So, in determining the characteristics of the rainfall is very important because storms differ in a number of characteristics. And these characteristics is very helpful sa pag-create sa mga hydrologic design to prevent floods or in order to ensure that the structure can withstand the design flood. So that's why it is important to determine the rainfall characteristics. So, unsa ang mga characteristics ng rainfall?
So, the characteristics of rainfall can provide important information for management, and land use may also minimize the water erosion problems. So, this video was carried out to evaluate soil and water loss in erosion plots with different coverage and interference of natural rainfall characteristics on this process. So, take note that there are three main characteristics of rainfall. These three characteristics of rainfall may vary from time to time, day to day, year to year, place to place. For example, the rainfall in deserts is different from the rainfall here in the Philippines. So these three characteristics is essential for planning its full utilization. So what are the characteristics of rainfall? First, the amount. Amount is defined as a fall or shower of rain, or it is the amount of water falling in rain, snow, sleet, fog, etc. within a given time and area, usually expressed as hypothetical depth of coverage. A rainfall of 70 example is a rainfall of 70 inches per year. Amount is of course important to the overall hydrologic cycle and replenishment of the soil water, and the amount is an accumulation of product of the intensity times the duration. For example, the amount may be the same for a high intensity short duration rainfall as it is for a low intensity long duration. So next characteristic is the frequency. So frequency refers to the probability distribution specifying the incidence probability of a different rainfall depths for a given duration such as 1 hour or a 24-hour day. So it is most of the time. So the frequency, or more specifically the return period, it is also called as I forgot it's the frequency curve. So it refers to how often rainfall occurs at a particular amount or intensity and duration. For example, rainfall return period, so the frequency of rainfall is referred as 100-year 1-hour rainfall or 100-year 24-hour. So that is the frequency. Next is the duration. So duration is defined as duration period of time during which continuous rain is observed or occurs at a given point or within a given area. So from the definition itself, duration is the gaano kahaba or how long is the rain, yung continuous, meaning hindi putol-putol. Duration is from very first raindrop until the last raindrop. So it is a characteristics of rainfall in which it is connected with the intensity. So anyways, all of these characteristics is connected to each other. So next characteristics of rainfall is the intensity. It is defined as the ratio of the total amount of rainfall depth that is measured by inches, centimeter, meters falling during a given period to the duration of the period. It is expressed in depth units per unit time, usually as mm per hour or meters per hour. So to have a deeper understanding of this rainfall intensity, let's watch this video by Miss Laura Jolly from YouTube. So let's just change this into YouTube and then play.
In this video, I'm going to further define and describe some of these characteristics of rainfall that are listed on the Camino page. So the first characteristic is intensity. And intensity I'm going to define a little bit more in a minute, but the intensity is the rate at which the rainfall occurs. And
so
it's also considered the depth
of
rain.
Temporal distribution of
good lines make like
rain.
half hour. A little bit better the intensity of a storm and duration. Okay, so I'm going to bring in this set of axes and try to draw on here for us, simulate a rainstorm. Okay, so I have on my x-axis time in hours, and I've marked it off every half hour. And then the y-axis is going to be total rainfall of the storm. So I'm going to just try my best here to make vertical dotted lines to make like a grid on here. Okay, and now we're going to simulate a storm passing by. And
She's
so let's say in
using
that
the
first half
inches
hour,
for the
it
unit,
rains and we accumulate in that first
for the
half
depth
hour
unit.
to half an inch of rain. Okay, and then in the next half hour, the rain increases and now we've gone up to 1.5 inches of rain. Slows down a little bit for a little while, and then after it slows down for a little while, we get another large increase in rain to get us to the 2 hours. Okay, so in the 2 hours, we've had a total of 2.5 inches of rain, but it wasn't a constant rain. Okay, so on the side, on the left-hand side, I'm just going to draw over here a cumulative rainfall to show that at the very end of the storm, it has rained those 2.5 inches. Okay, so again, going through the time, in that first half hour, we've gone up to half an inch of rain, and then it rains faster, so that in the next half hour, I've gone up to 1.5 inches of rain. Then it slows down a little bit, and then increases and increases until we've hit the 2.5 total inches
Looks
of
like
rain.
a rain gauge.
So what's really important to note here is that rainfall
This one.
intensity in a single event, in a single storm, can vary,
So it is the remarks.
and usually does vary, over time in a single event. And so this graph above is the rain, the temporal distribution of rain, so how much rain it is raining, the cumulative amount of rain in that storm. And so to get the intensity of that, the intensity is going to be the slope of that line. Okay, so we're interested in the intensity. We want to know how much it rains per hour, so that is the slope of that line. If we make a figure of the intensity, we call that a rainfall hyetograph. Rainfall hyetograph is going to be more like a bar chart. So I've tried to line up these axes right underneath the previous one. Did the best I could here. And so if I try to estimate, we know in that first half hour, the intensity, we got half an inch of rain in half an hour. So that has an intensity, right, of 1 inch per hour. And then it sped up, and in the next half hour, we got a full inch of rain. So that would be an intensity of 2 inches per hour. It slowed down a little bit after that for maybe about 15 minutes, and then it sped up a little bit more. Maybe then it was up here. For the remainder of the time, right? Okay, so this is what a rainfall hyetograph is, and it just shows intensity in inches or millimeters over time versus the time.
So the intensity there is, it explained that in half an hour, this is ours, the rainfall in inch, it is in half an hour there is half inch of rainfall. So the intensity will be 0.5 divided by time is equivalent to 1. That is, the intensity is 1 over, 1 inch per hour. So that is the intensity.
All right, so our discussion would be end here. So hopefully nasabtan ninyo about hydrology, hydraulic cycle, precipitation, and some rainfall characteristic. Okay, so thank you very much sa mga contributors ato ang video presentation. So you are all I want you to commend for your hard work. Okay, so if you have some questions, so drop by at the comment section or sa atong group chat. So see you again next